Hello, Year 11. I've been expecting you. Right, hello, Year 11. Thank you for completing or accessing yet another remote learning lesson with Miss Pitt. If you haven't already done so, please complete your retrieval quiz on your student worksheet. All you need to do is highlight the multiple choice answer for the question. So you've got a question, you've got 4 multiple choice answers, highlight the one that you think it is. Pause this video, come back for your answers. So pause me. Okay. So answers are as follows. A charged particle is an ion. They're formed when atoms gain or lose electrons. Cations are positive. Non-metals form negative ions. If magnesium's in group 2, it will become +2. If it's gained electrons, it must become negative, so the only one it could have been was the chloride ion. Monomers make polymers. Propene makes polypropene. Remember, we just take the poly away to find the monomer used to make this polymer. The functional group for an alkene is your carbon-to-carbon double bond. And how do atoms form ions? You could have got the answer from question 2. Atoms lose or gain electrons and become charged particles. So remember, if they lose negative electrons, they become positive. If they gain negative electrons, they become negative. So today we're only focusing on the positive ions, the cations, the metal ions. Remember, the only one that isn't a metal is hydrogen. Hydrogen also becomes positive, H+. So testing for positive ions using flame tests. So this is one of my favourite lessons to teach, especially in a lab. However, unfortunately, it is going to have to be done via a screen. Unfortunately, we won't be able to do the actual practico. It is a required practico for the GCSE, so you do need to be able to describe how to carry it out. Some keywords. So 2 keywords, a positive ion. A positive ion occurs when an atom has lost electrons and therefore it becomes positively charged. Now, positive ions are always on metal ions. A flame test is a technique used to test for positive ions, to find out what metal ions are in unknown compounds, unknown substances. So when heated, metal ions emit distinct colours of light. They give out distinct colours of light. And we can see this in the explosion of fireworks. The reason we get those nice colours is from metal ions inside of the chemicals. We can use these colours to identify which metal ions are found in compounds, are found in soaps. So I'm just going to play this video. You don't need to be able to listen to it, but you do. I think it's quite nice to just see it happening. So these are the group 1 flame tests. So remember, group 1 is your lithium, sodium, potassium, rubidium, cesium, francium. Oh, it's not going to load. Yes. See, lithium gives a nice red colour. So the heat actually gives energy to the metal ions and they give out light. Sodium, yellow colour. They use sodium in street lamps. That's why it gives a nice yellow glow. Potassium, I like potassium, lilac. Rubidium. You don't need to know the last 3. So it's the distinct colours that are given out by these metal ions that allow us to identify them. You can also see metal ions producing nice colours in the northern lights. Okay, so you do need to be able to describe how do you carry out a flame test. Okay, it's what we call a required practical. So there's 3 different methods. The classic method is the main method that is usually used. And if you can see in the picture, they've got a metal loop. So on the end of that metal pole is a small wire loop, a nichrome loop made of nickel and chromium. Sometimes people have them platinum loops. However, they can be quite expensive. So you've got your metal loop. You dip it, you hold it in the flame, and you dip it in acid. So before you put it in anything, firstly you need to hold it in the flame to make sure it's clean, to make sure that the flame's not changing colour to begin with. And you dip it in acid to get rid of any contaminants. So if the loop is contaminated, it needs to be cleaned. And we clean it by holding it in the flame, checking for any colour change. If there is a colour change, we know that it's contaminated. We can dip it in acid to get rid of the contaminants. Now, once we've cleaned our wire loop, we can dip it in the sample of compound being tested. So we've got an unknown soap. We want to know what metal ion is in it. We can dip the wire loop into that powder, into the soap. We can then hold the wire loop over the Bunsen burner flame, and we can observe the colour change. So whenever we do a flame test, we use a blue flame on the Bunsen burner, and as we hold the sample being tested into the flame should change colour. So it's just 4 simple steps. Heat the wire. Dip it in acid to clean it. Dip the wire in the soap being tested, hold it in the flame, and observe a colour change. Now, you do need to know these 5 colours. So lithium gives a bright red colour. Some people call it a crimson red. Sodium produces yellow colour, a yellow flame. So in the picture, you can see that actually inside of that sample, there must be sodium ions. Potassium gives a lilac flame. Calcium gives an orangey red flame. So it's more orangey than lithium. Lithium's more red, calcium's orangey red. And then copper, my favourite colour, not my favourite colour, but my favourite flame colour is green. Reminds me of Harry Potter and the flue powder. Now, the next method is what I call the easy method. It's soaking a splint in the soap solution. So rather than dipping it into the solid powder or the solid crystals, the solid compound form, the compound's dissolved in a solution, and then we can soak our splints in the solution. The splints absorb the solution. We can hold that into a flame, and it should give us a colour change. And again, lithium is red, sodium is yellow. I remember sodium being yellow, being in the street lights, and they give out a yellow glow. Potassium is lilac, calcium is orangey red, and copper is green. And then finally, the dangerous method, the spray bottle. So this is where you get a spray bottle, and we're hoping to keep the spray bottles once COVID's left, and we use them spray bottles to clean the table. Science are hoping to keep them to make these spray bottles. Pre-fill the bottle with a mixture of ethanol and soap dissolved in it. So we've got a soap solution. Remember, ethanol is an alcohol. We know that it's flammable. As we spray the bottle into the Bunsen burner, the droplets will become heated. The ions inside of the solution will gain energy and give out a light. Ensure, if we are doing this method, that you're not spraying it near any students. I know that some teachers have accidentally oversprayed, and the table is actually set alight. Luckily, ethanol reacts very quickly and it evaporates very quickly as well. But if we were doing this in a lab, I would be using the safety screen and making sure I had numerous safe heating mats down, and I would ensure that I won't let you do it. Some of you I might, some of you I wouldn't. You know who you are. Now, again, the colours you need to know: lithium is red, sodium yellow, lilac, potassium is lilac, calcium is orangey red, and copper is green. So task 1 on your student worksheet, I would like you to watch the flame test video. I'm a bit jealous because usually I'd be doing this for you. However, you've got this other teacher doing it for you. Fine. Watch the video, come back once you're done. Yes, she is very good. Her video is very clear and easy to follow. And I know that her favourite one is copper 2. Now, task 2, flame test colours. I want you to complete the table by adding in the flame colour produced by each metal ion. So you've got a table with the metal, the ion that's formed, and I want you to fill in the flame colour. If you're stuck, I've given you the colours you need to add. Pause the video, come back when you're ready to move on. Okay, so the answers are as follows. Lithium, crimson red, sodium is yellow, potassium was lilac, calcium was orangey red, and copper 2, it's copper 2 in brackets because it's got a charge of +2, is a nice green colour. So if you looked at the picture here, I could tell you that one there is copper, that one there is sodium, we've got potassium here, lithium right on the end, and we've got an orangey red one there, which must be calcium. Now there are other metals that do burn and give certain flame colours. For example, barium in group 2 gives an apple green colour. Very nice. So your next task is: Mr. James thinks he is funny and has told Mr. Capstack, our technician, that he has contaminated a bottle of and has contaminated a bottle powder with metal ion. So he's put a metal ion into a bottle of powder in the store, in the chem store, which actually we shouldn't really be going in, but Mr. James has got into the chem store and contaminated a bottle of powder. Now explain to Mr. Capstack, our technician, how he could identify the metal ion Mr. James has used. And as you can see, he's all ears, ready to listen to how he could test it. So you've got some bullet points, some sentences, you need to fill in the gaps. If you are stuck, the keywords are provided here in the yellow box. So pause the video, complete that task, come back for your answers. Okay, so he could have tested it using a flame test. He could use a nichrome loop to pick up the powder. Using a Bunsen burner on a blue flame, he could heat the sample. The metal ion will cause the blue flame to change colour. Potassium gives lilac. Copper gives green. Sodium turns the flame yellow. And calcium produces an orange-red colour. Now, finally, guys, that leads us on to our consolidation phase, which is an exam question. So a group of students have 4 colourless solutions in beaker 1, 2, 3, and 4. They don't know which solution is in which beaker. So they know what the solutions are. So you've got sodium chloride, copper chloride, lithium chloride, and potassium carbonate. But they don't know which one is in each beaker. So the teacher wants you to make a plan, make a method to test each solution to be able to work out which one is which. Pause the video, complete that task, come back for your answer. I said pause it. Don't just wait for the answer. Okay, so the answer should involve or include the following points. Now, you wouldn't have written it in the same way as me, okay, but the following points should have been included. You might have said use a splint or wire loop, dip it in the solution, heat it in the Bunsen burner, look for a colour change, repeat the steps for the other solutions. So remember, you do need to do it for every solution. And then it wanted to know what your results would have been. So the sodium would have given a yellow colour, copper green, lithium red, potassium lilac. Now, finally, guys, at the end of any good lesson, we evaluate our learning. So the learning intention was to be able to describe how to use a flame test to identify metal ions. Are you red? Are you amber? Are you green? So there is a section on the lesson to complete that. To complete your RAG rating, make sure you fill it in, please. It allows me a better understanding of how well you're doing from home. Thank you for completing the lesson. It's the same Year 11's doing it every week. It doesn't go unnoticed. It is very much appreciated. So thank you. I know my resources and my time isn't being wasted because some of you are accessing the work. Thumbs up from me.